Hello, my name is Phelan Kane. I'm a producer, engineer, Ableton certified trainer, and a synthesis and sampling obsessive. I also make Max for Live devices under the name Meta Function, and we're here in my studio in Berlin where I'm going to guide you through this tutorial to make the Sample Mash device. This is a buffer-based sampler that uses random numbers to create interesting novel sound design. So using the Max for Live environment, we'll be able to build an interesting sample playback device to provide unique sounds for your production. Let's have a look at the device. So let's see what our sample mash device is capable of. We have an instance of it loaded onto a MIDI track in Live, so let's click the load button. This opens a dialog window that allows you to load in a loop. It's important to know the BPM of your loop before you load it in, because we need that number to calculate a decent millisecond value for our glitching algorithm. In this example, my loop is 132 beats per minute. Once it's loaded, let's click on the loop button. This allows cycle playback, and let's press normal to begin playback from the beginning. This triggers a loop at its normal pitch and tempo. Normal rev plays it backwards. Double plays it twice as quick, which we perceive as a pitch shift. We also have fast, 4 times quicker, and 2 silly presets here, nuts, 10 times quicker, and bonkers, 100. Let's go back to normal. Now this loop is 132 beats per minute, and we know that there are many online BPM to millisecond calculator websites available. At a BPM of 120, we have a quarter note landing every 500 milliseconds. I'm going to be using the awesome Music Math app. At 132 beats a minute, a quarter note lands every 454 milliseconds, an eighth note every 227, and a 16th every 113. So let's type 113 into our millisecond parameter and switch on the drunk button. We're now glitching the end point of our loop via a random number generator at 16th notes. And we can change the step size of the random number generator via our 2 little presets, loads or little. And the loads button gives you a much wider range of random numbers generated from the algorithm. So we can use all these together to create interesting, crazy, novel sound design. So there's the sample mash device. Let's see how we can build this. So here we are in Live. We have a blank MIDI track created. So let's visit the browser. And we're going to go to the Max Instrument category, which is located inside the Max for Live category in the browser. Let's open up the drop-down arrow. And we're going to load in the blank default template, which is called the Max Instrument. This provides us an empty shell to build into. So let's drag and drop this onto our MIDI track. And you can see we've got an instance of this device loaded, and there's not much going on. To save screen real estate, let's shut down the browser. And we're going to come down to the device view. We can see here we have the edit button, and this is going to launch the Max for Live development environment. So by clicking that, we've actually booted Max. And Max for Live really is a bridge between the worlds of Live and Max. It's really a software license that allows you to take leverage of all of the bonkers crazy possibilities of Max within your DAW inside Live. So this is actually now running Max as a separate application. And obviously we have Live running in the background. And the Max for Live protocol allows us to utilize these 2 worlds inside the DAW. So let's come back to Max. So here's our patcher window. Let's reposition this and make it a bit bigger so we can see what we're doing. And we've got loads of different sort of options around the side panels to be able to sort of do different types of patching. But first up, we're just going to select all the objects that are in this default template and delete them. We don't need to use any of these objects to start with. We're going to make our own stuff. Okay, one good thing to begin with is to right click in the background of the patcher and to choose the inspector window. This will open a floating window which allows us to configure the properties for the entire patch. And it's a good idea to do this at the beginning because it's quite easy to forget this. What we want to be able to do is visit the Basic tab inside our inspector and activate the opening presentation mode by simply switching the tick box on. This means when we save our patch later and we load it into live, we'll be able to present the patch in presentation mode to the user, allowing the user access to the graphical user interface. So let's close down our inspector. There's a couple of important tools we need to use. We have in the bottom left-hand corner of the patcher, the padlock. This allows us to lock the patch so we can interact with it as a user, or unlock it and interact with it as a builder and make objects. So while the patch is unlocked, let's simply press N for new, and that opens up a floating text box, and we can type in the name of the object we want to create. So the core of the sample match device is the groove object. So let's simply type in groove. We can see here we have an autocomplete as Max for Live tries to help us identify the object we're looking for. And we're going to use the groove object, which is a variable rate looping sample playback object. And if you notice, there is a wiggly line at the end of the name, a tilde, and that represents it's an MSP or audio object. There are several different categories inside Max for Live and Max. So we're going to focus on utilising some MSP or audio objects in this tutorial alongside some basic Max objects. So let's create our groove object. Now, one of the great things about Max is the help menu is really comprehensive. It gives you a whole bunch of different options that are really useful. Whenever you make a new object, if you control click or right click on it, you see a floating contextual menu and we can visit the groove help window. So if you're ever sort of trying to learn a little bit more about some of these objects you might be using in Max, we can see the help is really useful. And we've got a whole bunch of different descriptions here about the functionality of the object in question. So let's close down the help view for now because we don't really need it. And the groove object has 3 inlets. If we hover over the first inlet on the left-hand side, you see that inlet needs a signal coming in, which represents the sample playback increment. The second inlet is going to provide a signal or float, which will be our loop minimum. This is the beginning of the sample playback. The third inlet is going to be the loop maximum, and this represents the region inside the waveform that the groove object will be playing. Let's have a look at the first outlet, and that is going to be providing channel 1's audio signal. And the second outlet is going to be providing the loop sync output. We're not really actually going to use that in this tutorial. So let's first up build a fader to provide some gain staging for the output section of our patch. Let's press N for new and we'll type in live dot. The live dot objects have a funny name, but they represent the Max for Live objects. And these are configured to ensure good compatibility within the live ecosystem. For example, using a live dot object often allows you to implement automation within the host DAW Live. So whenever you're building stuff in Max for Live, it's recommended to take leverage of your live dot objects as much as you can. So we're going to go for a live dot gain control. This is a decibel volume, slider and monitor. So this is a little fader which we can stick into our graphical user interface and give to our user to allow some gain staging of the output of the device. Let's simply roll over the first outlet of the groove object, click and drag the virtual cable into the left-hand input of the live.gain object. This is a stripy cable, it's a bit like a tiger's tail. This represents an audio signal. So we'll be running audio signal down this cable at sample rate in your device. So we could do a bit of cheating here and do some fake stereo. Let's also drag a cable from the left outlet of the groove object into the right-hand side of the live.gain. So we're really here mimicking the audio signal from the groove object to the left and right channels of the live.gain object to provide some fake stereo. So the output section at the bottom here on the live.gain has got multiple outlets. There's quite a few outlets here. And again, if you hover your cursor over them, you'll get a little rollover explaining the functionality of each outlet. Now, to see these a little bit better, it might be good to stretch out the width of the live gain. Then it's a bit easier to get to each outlet. The first outlet represents the left-hand signal of the live.gain fader, channel 1. The second outlet is channel 2. And from outlets 3 upwards are additional types of data which we're not really going to use in this tutorial. So let's make a new object underneath this, N for new, and we're going to type in plug out. And this will be a MSP audio object with a tilde, and this represents the object that passes the audio from our Max for Live patch back into live. So this is the output stage of our device. And we're simply going to cable up the first outlet of the live gain into the first inlet of the plug out, and the second outlet of the live gain into the second inlet of the plug out. There's a lot of parameters we can configure inside Max and Max for Live. Let's select our live.gain object, and we make sure it's highlighted. Let's visit the inspector on the right hand side of the patcher, and the inspector allows you to configure properties from the currently selected object. So if you ever used anything like Photoshop or Adobe Illustrator, you're probably familiar with the fact you can configure properties for selected objects, and Max is no different. So let's visit the All button in the inspector to see all the parameters available for the live.gain. And we can see here we've got a lot of different customization we can do, changing colors, changing position, changing names, labels, etc. But what we really want to do to begin with is configure this slider to be working in a horizontal orientation. This will give us a little bit more space in our GUI. So now we've built the main output section of our patch, and often in the Max for Live environment, it's quite useful to reposition objects to be able to maintain decent screen real estate. Okay, the groove object is the heart of the patch, so let's stretch this out a little bit to make it a bit wider by clicking into the bottom right hand corner of the object. And we can see we can quite easily now get into the different inlets. So we're going to be using a waveform object to provide the position in the sample for the start and end of the playback. And we're going to be using inlet 2 and 3 of the groove object to send data from the waveform object into the groove. So let's press N for new, and let's type in waveform. And you can see this is a buffer viewer and editor. Once that's created, we can then roll over the different outlets of the waveform. And we can see we've got various different outlets that transmit data. And we're going to be looking for the third outlet from the left, which is the selection start in milliseconds. So let's wire a cable from the third outlet in the waveform into the second inlet in the groove. We also want to send a cable from the fourth outlet of the waveform, which represents the selection endpoint of the sample. And let's drag that into the third inlet of the groove. So we're getting closer now. We're going to use the waveform object to determine the length of the sample that the groove object will play back. There's a few other important things here to do. We need to tie together the groove object and the waveform. Let's go back to the groove object and have a look in the inspector. And we can see if we scroll down to the bottom, we have multiple different sort of parameters we can mess with, and we can do all sorts of different types of interpolation. What we really want to do here is we want to be able to configure an argument name for this groove. So let's simply double click on the groove object, and we're going to arrow to the right and add a space. A space is super important. And let's type in sample mash. So we're using an argument here, and the argument is a parameter that allows us to configure additional operations for the groove object. So arguments are really driven from the computer science world, where we provide arguments into functions to allow us to pass variables, names, etc. through to different objects. So we've now labelled our groove object with the argument sample mash, so our groove is going to be referring to a sample mash argument. Okay, the third most important object we're going to be using inside our patch is a buffer object. So let's press N for new, and let's type in buffer. This will be an audio object with a tilde, and it actually allows us to store audio samples. So this will represent the piece of RAM that we'll be loading the sample into, and the buffer needs to communicate with the groove object. So it's super important to configure your buffer correctly. So let's actually put an argument into the buffer object. Let's double click on it. And again, we'll arrow to the right and add a space. A space is really important. And let's type in sample mash. So be careful here with your spelling and typos. This is case sensitive. We're labeling the buffer with the same argument we're using for the groove object to allow them to communicate. If this is not set correctly, the device will not be passing audio from the buffer to the groove. Okay, so the buffer represents the audio file you're going to load. If we were to right click on the buffer and have a look inside the help, we can see there's a whole bunch of other stuff that we could use to configure the buffer. There's an awful lot the buffer can do. And you can see here the buffer actually talks to the waveform object as well. Let's come back to the very first page of our buffer, and we can see in the help there is a message box here called replace. And the replace message box allows you to open up a dialog window for the user to load an audio file into the buffer. So let's close down the help, and we're going to configure and construct a new object. This time we're going to press M for message. And in the message object, let's type in the words replace in lowercase. So we're configuring here a replace message box, which we're going to connect to the input of the buffer. So the replace message will configure the system to open up a dialog for your user to allow them to load in a sample. The message box is really funky, however it's maybe not the most sexy thing in the world. So let's make a new object, N for new. Let's type in live.button. And we can see we have a graphical user interface object here for the Max for Live family, which is a button. And with a button object, we can place this onto the GUI and use it to trigger the replace message. So we're simply going to take the cable from the output of the button into the input of the replace. The button's a bit of a nicer GUI element than the replace message. This button will transmit a bang or a one message to trigger the replace message, which then is by default activating a function from the buffer object. So this button here represents our load. Let's actually label this up for the graphical user interface. Let's press C for comment, and we're going to type in load. So we're using a comment here to label up an aspect of our patch, and we can see the load comment we've got here. We can position right next to the button, and we're going to display both of these onto the graphical user interface to give the user some insight into what the button actually does. Okay, this leads into the idea of using presentation mode. So let's select the button and the load message. Let's select the waveform via shift clicking, and let's use control click or right click to open the contextual menu. And let's add these objects to presentation mode. So let's select add to presentation. So not much has changed, but we need to configure our presentation. Down in the bottom of the side pane in the patcher, we can edit presentation mode. This allows us to set up the graphical user interface layout for the patch. So if we hit presentation mode, the objects that we've configured into presentation mode appear. And you notice there's a little thin black line running across the patcher, and that black line represents the maximum device height you can use in pixels for the Max for Live device in Live's device view. And if you position any objects below this line, you'll be cropping those objects out of the GUI. It's kind of important to make sure that your objects are actually always above this line. Let's move the load and the button over to the left-hand side, and you're free to configure these wherever you like within your patch. Probably also make our waveform a little bit bigger by dragging out the bottom right-hand corner. Let's go back to building mode by exiting patching mode. And we've got a few more things we need to do here. We need to configure how the buffer is really going to be working. So we need to pull out some info from the buffer. Let's press N for new, and we'll type in info. This is an object that will report information about a sample. So we're going to use this to report the information about the sample the user has loaded into the buffer object. So let's again arrow to the right and press space. And again, we need to configure the correct argument. And we're using sample mash as our argument or identifier to link the buffer with the info with the groove. So the info object is kind of useful because it allows you to pull out loads of different bits of information of the loaded sample. If you hover over the outlets, you'll see you have information that could be pulled out, like the sampling rate of the file, the sample instrument info, stuff like sustained portions, maybe even sustained loops. There's quite a lot of information we could pull out here. We're only really going to be using one outlet for this object, and that is the third from the right, which represents the total time. So this is the total time in milliseconds of the duration of the audio file that's been loaded. So we need this as we need to set up the maximum duration for the glitch process. So let's make a brand new object underneath this. We'll press N for new, and we're going to type in the words flow num. Now flow num is a max object, not an MSP, so it doesn't process audio. However, it displays and outputs a number, most notably a floating point number. So a number that is with a decimal place. So we see here the little object is created with a decimal place to the right of the value. So we can load into here a float value. Let's take the third outlet from the right into the input of the flow num object. So when the sample has been loaded, this box will be populated with its duration in milliseconds. Okay, so brilliant. We've got a little bit more configuration to do here. So I'm going to select my waveform and my groove and pull it down a little bit. And what we want to try and build now is going to be some controls to manipulate the start and end point of the buffer. So what we want to do is we want to make ourselves a couple of objects that allow the user or the device itself to actually configure the start and end points of the chosen section of the waveform. And we can fire into the inlets in the waveform different values that represent the start and end points of the sample. So let's make a new object, n for new. And let's type in live.num. And you see this is a live.num box, which represents a number. Again, it's a graphical user interface object that is mirroring the GUI style of Live itself. And this object here, we're going to connect the left-hand outlet and we're going to patch it into the selection start inlet in the buffer. That's the third inlet on the left. So once again, it might be quite useful to provide some information for the user of what this actual box does. So let's press C for comment. Let's type in start milliseconds and we'll position that right next to the box. So once again, you need to label up certain controls within this environment to be able to give the user a clue of what's going on. Let's select the box and the comment, right click and add to presentation. Let's quickly dive into presentation mode. And again, we can configure these wherever you like inside your interface. So it's really up to you how you want to display the different parameters in your GUI, completely customizable. Let's go back into building mode. And we can see we now also need to configure the endpoint. So let's cheat. Let's select both the box and the comment and copy and paste. Now we can simply change the text in the comment box from start millisecond to end. And let's drag a cable from the outlet of the number box into the fourth inlet of the waveform. So these little controls now will be configured to allow choosing a certain selection of the buffer for playback. Let's visit presentation mode again, and you can see we need to configure our interface for our end controls. Okay, let's go back into the building mode by exiting presentation. The far right inlet of the waveform object allows you to pull in a link in, but we're going to use this particular section to allow to select all of the waveform. So let's right click onto the waveform object, open up the help. And we can see a little example here in the waveform where we can use a message box with some messages here to configure to select the entire waveform. So for example, we can see here I can actually manipulate some of the start and end parameters to define a certain section in our waveform. Or I could click the message box to configure and select the entire waveform. When a user loads an audio file into the buffer, we want the patch to automatically select all of the waveform in its entirety. Let's unlock the help for the waveform patch. And let's simply select the message box and copy. Let's close down our waveform help. And we'll paste the message box into our patch. So you can see the help is awesome in Max because you can literally copy and paste elements of the help into your own patches. And it's a great tool for reverse engineering how things work and taking bits of existing work from the help and deploy them in your own workflow. Let's move the message down towards the far right inlet of the waveform and connect it up. So this is going to be a message we're going to utilize to select the waveform in its entirety. Once again, we should probably copy a comment and label what this control will be for the user. So let's enter select tool into our comment box. And again, we're going to use a button to trigger this because it looks a bit nicer on the interface than the message box. And we can take the button we made earlier as part of the replace section of the patch. We'll copy and paste that. Bring the copy down, and wire it into the first inlet of the message box. Once again, we want to make sure both of these objects are in presentation mode. They should be by default because we copied them. Let's go into presentation mode, and we can configure our new GUI elements wherever you like. Let's come back to builder mode. Probably a good idea now to save our device. So let's visit the File menu inside Max and choose Save As. And by default, Max is pointing us towards the Max Instruments folder, which is part of the Instruments folder within your user library. So it's really important to save your devices in the default location when you're working in Max for Live, and that way your devices will show up in the browser in Live. If you move this to a different path name, it will not be visible in the browser in Live. So it's good practice to save your patch into the default location, which is part of your user library. So let's give this a title. I'm going to call it Sample Mash 2, because I actually have one already in there, and I don't want to wipe over the final version. And you can see now, in the background in Live, we've actually loaded the device in, and it's been configured to open in presentation mode to be able to show us the GUI elements we put into presentation. So that concludes the first part of building the Sample Mash device. Come back for part 2.